Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the Terminator lab. This is the video number 32. We have been discussing in the previous video the following. I've been working now for 10 videos on how to create an MDT and WDS environment to deploy Windows 10 to a large number of PCs at one time or automatically. So we have been following the footsteps of David Brother Barbarius YouTube channel. This guy has made a fantastic documentation how we can prepare a lab or prepare an environment to deploy Windows 10 using the MDT and WDS. MDT is an abbreviation for Microsoft Deployment Toolkit, and WDS is an abbreviation of Windows Deployment Services. So we have been following the footsteps of Daniel Brother Barbaris documentation, which is called steps. We have stopped the last time at this line. Before that, we have been preparing the WSOS or the Windows Server Update Service to be, or are preparing the WSOS to be prepared when we deploy the Windows 10 machines. The WSOS will be responsible for pushing the updates for Microsoft products to these deployed Windows 10 machines. Okay, we need to approve some updates. We need to decline some updates. So that was what we, or what this was what we were doing the previous video, and we have accelerated the process of downloading the updates through the WSOS by activating a service called a background intelligent transfer service. It was used once and then we disabled this service because it is very critical service. Most of applications depend on it for downloading files. Okay, so it should be used once and then to be disabled. Okay, it will be brought something called foreground, or it will be focused on only downloading updates for the WSOS, and then we will return it back to its normal state to serve all of the applications that need its service to download updates, okay, or download files. Anyway, so we have done this in the previous video. Today we will begin a new, or we'll begin the real work. Now we will begin working with the MDT. We need to go and prepare our MDT. We have two processes. We have the capture process and we have the deployment process. So we need to prepare the MDT. We will create two folders, one for the capture and one for the deployment, and we need to prepare it to import the operating systems that will be used to install Windows. So we need, for example, to capture Windows 10, so we need to import Windows 10 operating system to the MDT. And for example, if you need to deploy Windows 11, you need to import the Windows 11. So we'll do a couple of steps. We need to prepare the MDT for the process of capturing and deploying. Okay, so we need to do both things. So before that, we need to have a look on the process of the MDT. What will be the process? If we have this graph was from my previous lab, the DC Comics lab. So this is the process of the deployment. So we have a PC that doesn't have any operating system on it. We have our server. Actually, this is not the server in our lab. This was in the DC Comics lab. Anyway, this server will have DHCP on it, will have WDS on it, will have MDT on it, and WSOS. So this is a very important server. So what will happen when this PC is powered on? It doesn't contain any operating system. It will boot in a mode called Pixie boot mode. This mode is specially designed to communicate or to point to a certain server, so this PC can gets its operating system from this server, or to install its operating system from this server. So what will happen? It will go to the Pixie mode, and then before pointing to the WDS, or before pointing to the MTT to get its operating system installed, it should first seek an IP address. So the Pixie boot mode will go to the DHCP server and get an IP address, and then it will be pointed to the WS, which will contain the boot image. This is a special Windows or a mini operating system that its main function is to help us to install the operating system of Windows and the applications. Okay, so this is the boot image. So the Pixie boot will get an IP, then it will go to the WDS and get its boot image, and then the boot image will point to the MDT capture folder or deployment folder. This contains a task. This task, for example, if you need to deploy Windows 10, this is a task. This task will be done exactly in order. So for example, the first task is to install Windows operating system. This will be included in the MDT folders. And the second thing is to install software. This also will be included in the deployment or the MDT folders. And then after that, for example, you need to join this PC to the domain and get a name. This also can be done. So this is a task we will create in the MDT, and these are folders created in the MDT that will contain the source programs and source operating system that will be deployed. Okay, so we will go to the MDT, we will see the task. These scripts will help us to uh, implement the task. For example, one of these scripts will make two partitions, C and D, on the computer. It will format the hard disk of the PC and make it two partitions. Another script will install the software silently. So these are all scripts that are in the MDT folders that will help us to implement the task. So after installing the operating system, installing the software, and joining the PC to the domain and give it a name from the MDT database, we will have a database that will contain the names of the PCs that will be given to them before joining the domain. At the end, we will have a PC that has the operating system installed on it with all of the necessary programs. Okay, so this is the life cycle. After having this PC installed Windows operating system on it and necessary programs, we need to take an image of it. Then we can deploy it to several PCs. So this task, it is not a deployment task, it is a capture task. So because this is for an old lab, so let's change it from deployment task to capture task. So this is a capture task. We will install Windows operating system, install the software, and then we will capture an image. But before capturing an image from this PC, we need to make a sysprep process. Okay, this is one of the important things. Sysprep is very critical process. Without doing it, we will not be able to deploy this capture image to a lot of PCs. Let's first see some explanation about what is a Pixie boot mode, what is a boot image, what is a WinPE operating system. All of these are things we need to know about it. If you all know about it, we can give an abbreviation for some people that doesn't know these terms. And we need to know what is sysprep. So let's see what Google Bard had to say about this thing, or what is the Pixie boot mode. Let's see what Google Bard had to say about it.
System PXE boot, also known as network boot, is a process that allows a computer to boot from a network server instead of a local hard drive. PXE stands for Pre-boot Execution Environment, and it is a set of standards that enables a computer to load an operating system, OS, over a network connection. PXE boot is commonly used in enterprise environments to deploy and manage operating systems on multiple computers simultaneously. It can also be used to boot computers into a diagnostic environment or to recover from a system failure. To boot a computer into PXE mode, it must have a PXE-enabled Network Interface Card, NIC. The NIC will broadcast a request for network boot information to the DHCP server. The DHCP server will then respond with the IP address of the PXE boot server and the name of the boot file. The client computer will then contact the PXE boot server and request the boot file. The PXE boot server will send the boot file to the client computer using the Trivial File Transfer Protocol, TFTP. The client computer will then load the boot file into memory and execute it. System PXE boot has several advantages over traditional local boot methods, including reduced costs. PXE boot can help to reduce the costs associated with operating system deployment and management. By deploying operating systems from a central server, IT administrators can save time and money on tasks such as distributing installation media and troubleshooting boot problems. Increased efficiency. PXE Boot can help to improve the efficiency of operating system deployment and management. By booting multiple computers from a central server, IT administrators can deploy operating systems to multiple computers simultaneously. Improved security. PXE Boot can help to improve the security of operating systems. By deploying operating systems from a central server, IT administrators can ensure that all computers are running the latest security patches and updates. System PXE Boot is a powerful tool that can help IT administrators to deploy and manage operating systems more efficiently and securely.
So we can see here this is a very detailed answer and a very clear one about what is a PXE or system PXE boot. There is something here added to Google Bard. You can double check response, so he will go and search the internet to see if the generated answer is correct or not. This was added recently, so you can see, for example, all of the highlighted green text. That means that he find a source to get this answer from. If you click on here, you will see Google search found similar content like this one. He got his answer, or his answer matches an answer from Microsoft. Okay, but what about this one, or this brown answer? Here he says that he didn't find relevant content. Anyway, that doesn't mean that this answer is not correct, but he didn't find someone to match, or someone that is have the same answer he has generated. For example, he say, by deploying operating system from a central server, IT administrator can save time and money on tasks like distributing installation media and troubleshooting boot problem. This is very logical answer, and this is correct one. But he searched the internet to see if this answer is submitted in a website or something. He didn't find it, but that doesn't mean that the answer is not correct. By this new option added to Google Bard, you can verify that the answer is correct, and this is very useful one. And if this answer is a little bit complicated, you can tell him, for example, if you go there and see here, there is something you can tell him to make it more simple. So for example, I asked him to explain in more simple terms. Let's see what was the answer.
System PXE Boot is a way to start your computer using the network instead of your hard drive. This can be useful for installing a new operating system, troubleshooting problems with your hard drive, or recovering from a system failure. To boot into PXE mode, you will need to enable it in your computer's BIOS or UEFI settings. Once PXE Boot is enabled, your computer will start looking for a network server to boot from. If it finds a PXE boot server, it will download the operating system or other boot image from the server and start it. Here is a simple explanation of how System PXE Boot works. 1. You turn on your computer. 2. Your computer looks for a network server to boot from. 3. If it finds a PXE boot server, it downloads the operating system or other boot image from the server. 4. Your computer starts the operating system or other boot image. PXE Boot can be used to install and deploy operating systems on multiple computers simultaneously. It can also be used to boot computers into a diagnostic environment or to recover from a system failure. Here are some examples of when you might want to use PXE Boot. You're installing a new operating system on a new computer. You are troubleshooting problems with your hard drive. You are recovering from a system failure. You are deploying a new operating system image to multiple computers. You are booting computers into a diagnostic environment to troubleshoot problems. PXE Boot is a powerful tool that can help you to deploy and manage operating systems more efficiently and securely.
So we can see here this answer is more simple, so we can understand it. Maybe the other answer was a little bit formal and complicated, but this was a short, clear, simple answer. So let's continue and ask him other things. What is a boot image? So for example, what is a boot image? Let's see what Google Bard has to say about it. If you go there, what is a boot image? Let's see what is a boot image.
A boot image is a type of disk image that contains the files and information necessary to start a computer. It typically includes the operating system kernel, bootloader, and other essential system files. Boot images can be used to install a new operating system on a computer, or to recover from a system failure. Boot images can be created using a variety of tools and methods. For example, you can use the Windows Assessment and Deployment Kit, ADK, to create a Windows P boot image. You can also use third-party tools to create boot images for other operating systems, such as Linux and macOS. Once a boot image has been created, it can be written to a variety of media, such as a USB drive, CD-ROM, or network server. When you want to boot a computer from the boot image, you simply need to change the boot order in the computer's BIOS or UEFI settings. Boot images are a valuable tool for IT administrators and power users. They can be used to quickly and easily deploy operating systems to multiple computers, or to recover from system failures. Here are some examples of when you might want to use a boot image. You are installing a new operating system on a computer. You are troubleshooting problems with a computer's operating system. You are recovering from a system failure. You are deploying a new operating system image to multiple computers. You are booting computers into a diagnostic environment to troubleshoot problems. Boot images can also be used to create custom boot environments, such as a bootable version of Linux or a bootable rescue disk. This can be useful for a variety of tasks, such as recovering data from a damaged hard drive or repairing a corrupted operating system. Overall, boot images are a powerful tool that can be used for a variety of purposes. If you are an IT administrator or a power user, it is important to understand how to use boot images.
So boot images are a mini Windows operating system or a mini system that is used to troubleshoot PCs, for example, that has their operating system corrupted or not loaded, or on PCs that doesn't have any operating system at all. So this is a bootable operating system that boots from a CD, not from the local hard disk of the machine. So this is very, very useful. For example, in our lab, we will use it to connect to the MDT server and begin the installation of the Windows operating system. So this is one thing very, very important. But let's have another question. What is a boot image and how it is used with MDT, and is it the same as WinPE? So I have a little bit of a confusion. What is a Windows PE? Okay, it is used in conjunction with boot image, but what is the difference? Okay, so let's see again what is the answer of Google Bard. And do not forget, if you need to double check the response, it will go to the internet and check if the response is correct or not. Okay, so let's see the answer.
A boot image is a type of disk image that contains the files and information necessary to start a computer. It typically includes the operating system kernel, bootloader, and other essential system files. Boot images can be used to install a new operating system on a computer, or to recover from a system failure. MDT, Microsoft Deployment Toolkit, is a free tool from Microsoft that can be used to deploy operating systems to multiple computers. MDT uses boot images to boot computers into a temporary environment where the operating system can be installed. MDT boot images are typically based on Windows P, Windows pre-installation environment, which is a lightweight operating system that can be used to install and manage Windows operating systems. MDT uses boot images in the following ways: to boot computers into a temporary environment where the operating system can be installed, to capture images of existing operating systems, to deploy operating systems to multiple computers simultaneously, to troubleshoot problems with operating systems. No, not all boot images are WinPE boot images. Boot images can be created for a variety of operating systems, including Linux, macOS, and Windows. However, WinPE is the most common type of boot image used with MDT. Here are some examples of how boot images are used with MDT, to deploy a new Windows 10 operating system to a fleet of new computers. To capture an image of a Windows 11 operating system that has been customized for a specific organization. To troubleshoot problems with a Windows Server 2022 operating system. MDT boot images are a powerful tool that can be used to deploy and manage operating systems more efficiently and securely.
So here you can see what is the relation between the Windows PE and boot image. Windows PE, it is used to create a boot image. This is used to troubleshoot problems on operating systems, or to install new operating systems, or to diagnose problems with operating systems. So this is the relation between the boot image, the WinPE, and the MDT. So these are all things related. What is the sysprep process? We have said here before that after this PC is had its operating system installed and programs, we need to capture an image to be deployed. But before that, we need to make a sysprep. What is a sysprep? Let's see what does Google Bard has to say about it.
The sysprep, system preparation, process is a tool used to prepare a Windows installation for imaging or deployment. It does this by cleaning up the system and removing any unique identifiers, such as the computer name and security identifier, SID. This makes it possible to deploy the same image to multiple computers without any conflicts. The sysprep process can be used in two different ways. Generalized, this option prepares the system for imaging. It removes all unique identifiers and resets the system to a factory fresh state. Specialized, this option prepares the system for deployment. It removes some unique identifiers, but it leaves others intact, such as the computer name. This allows the system to be deployed to a specific computer without any conflicts. To run sysprep, you can use the sysprep tool that is located in the Windows System 32 folder. You can also run sysprep from the Windows command prompt. Once sysprep has been run, the system will shut down. You can then image the system or deploy it to a computer. Here is a simple explanation of the sysprep process. 1. The sysprep tool is run. 2. Sysprep cleans up the system and removes any unique identifiers. 3. Sysprep resets the system to a factory fresh state or prepares it for deployment to a specific computer. 4. The system shuts down. 5. The system can then be imaged or deployed to a computer. Sysprep is a powerful tool that can be used to deploy and manage Windows operating systems more efficiently and securely. However, it is important to note that sysprep can be destructive if it is not used correctly. It is important to understand the sysprep process before using it. Here are some examples of when you might want to use sysprep. You are deploying a new Windows operating system to a fleet of new computers. You are creating a Windows image that can be deployed to multiple computers. You are preparing a computer to be imaged. You are recovering a computer from a system failure. If you are unsure whether or not to use sysprep, it is best to consult with a system administrator.
So we can see this is a very simple explanation what is a sysprep. But still, if it is not clearly explained, we can tell him to tell Bard to use analogies. This giving you examples to or to relate examples similar to sysprep. So for example, he will give you an example. What is the sysprep? For example, you can for example, when I explaining to my kid the for example, that Earth and Sun, uh, uh, how they are big or small, so I can tell, for example, my son that the sun is like an orange and the earth is like a lemon. So this is called an analogy. Here we can tell him to explain sysprep using analogies. So let's see what he has to say about it.
Here is an analogy to explain the sysprep process. Imagine that you are preparing to sell your house. You want to make sure that the house is clean and ready for the new owners, so you hire a cleaning company. The cleaning company comes in and cleans the house from top to bottom. They remove all of your personal belongings, including your furniture, clothes, and photos. They also remove any unique identifiers, such as your name and address. Once the cleaning company is finished, the house is ready for the new owners. They can move in and start their new life in your house. Sysprep is similar to the cleaning company. It cleans up the Windows installation and removes any unique identifiers. This makes it possible to deploy the same image to multiple computers without any conflicts. Here is another analogy. Imagine that you are baking a cake. You want to make sure that the cake is the same every time you bake it, so you use a recipe. The recipe tells you exactly how much of each ingredient to use and how long to bake the cake. SysPrep is like a recipe for deploying Windows operating systems. It tells you exactly what steps to follow to prepare the system for imaging or deployment. This makes it possible to deploy the same image to multiple computers without any conflicts. I hope these analogies help to explain the SysPrep process in a simple way.
So here you can see this analogy is perfect to explain what is sysprep. Another thing to make the sysprep more simple to understand, let me show you a little bit of a graph about sysprep, or a clear picture. For example, this is me. For example, I am a person named Karim Raouf. I have lost my memory. Then they clone me 3 clones. Okay, what they have done, they have given them other names, okay, and identity. So I have here, this is my name and I have an identity. I lost my memory, okay. So what they have done, they have cloned me 3 clones, and then they give the 3 clones different names and different IDs. So now we all have the same shape or the same look, but we are different. We have different IDs and different things. So they have my shape, they have my body, they have my eyes, they have my hair, they have the same body specs or specifications, but they are now having different names and different IDs. The same will be done for the PC. So we have the PC, for example, something called PC Marvel 17. We will capture an image of this PC and then we will make a sysprep. The sysprep, it's like making lose my memory. Here we will make sysprep, so the PC will lose his memory or will lose his identity. Then we can apply the image to different PCs. They will have different names and different identities. The same as like I am the same here, like I am cloning myself. So this is the same process. We are having a PC that will capture each image or capture an image of it, and then we will make sysprep. This will make it like losing my memory. Then we will clone it, okay, different, or we will push it to different PCs, and then we will give every PC the same or different names. So they are, what are in common between this PC and the other PCs? They have the same Windows, the same programs installed, but they have different names and different identities. So this is basically what we will do. Okay, so in this also video, or this video will prepare ourselves to make a capture process. Let's see also another graph about the capture process. So the process here, this is the PC. We have everything installed. We have Windows 10 and other programs. So this is it. We will go to the MDT, okay, or the MDT will, we will have a task to capture the image. So what we will do, this PC will boot, and then all of the operating system and programs will be installed. Then we will capture an image of this PC, and before that we'll make sysprep. So we'll make sysprep and then take an image, okay, and then this will be deployed later. So this is the process. We need to prepare the MDT to do this process. So we'll have 2 phases, the capture phase and the deployment phase. So let's see how all of this will be done. We need to prepare ourselves to do this. So let's go and see how this will be done. Okay, so let's go and open the video. So this is the Oracle VirtualBox that contains our virtual machines. We have 3 servers. We have the primary domain controller, we have the additional domain controller, we have the file server, the WSOS server, the WDS server, the MDT server, the WSOS server, all in one server. Okay, so we need in this process to open the primary domain controller and the MDT server. Okay, so before doing anything, we need to take a snapshot. This is very, very critical if you are making a great change to your operating system. So you need to take a backup or take a snapshot if this is a virtual machine. Okay, so we need to begin working with the MDT. So now we will take a snapshot. Okay, before MDT shares configuration, so we need to or this is the name of the snapshot. So here we can see there is a small rectangle that it is black. This was a problem. Okay, I thought this was a problem from my display card or something, but this was a software that was not closed correctly. It was something called Power Toys. This is one of Microsoft programs I have already installed on my PC. So this was hanged. So I need to close it so this black rectangle will disappear. So this was a problem. Here I'm taking a snapshot. So I need to go and close the program. Here we can see this is the program, the one beside the virtual box. Okay, so now I can see I have realized the problem. I need to close the software. Okay, so I try to make a refresh. I thought this was something with the uh, display card, but it was a problem with this software. Okay, so I try to close it manually by right click and close, but it didn't properly close. It's called Power Toy Color Picker UI. This was the program. I tried to close it by this way, but it was not closed, so I forcibly shut it down, okay, or close it. So now we will close the program. Then we will open. This is the MDT server. We will log in with the domain admin account. So we'll use Keraof. This is domain admin account. Just pause the video. Now we have, or we have logged in. Now we need to check and see. We need to check some services in the Windows to make sure that we can work with the MDT. Some of these services, for example, I need to make sure that the WSOS is working and the SQL database is working, because I will create a SQL database that is attached to the MDT. This database will store the name of the PCs that will be given to the deployed machines to join the domain, okay, or before joining the domain. Now we can see the services. Remember, we have created a scheduled task in Windows to start these services automatically, but here I am trying to make sure if you don't have this kind of task created, you need to go and see if these services are running or not. So for example, we will see, for example, that the Windows internal database is not working. This is related to the WSOS, okay? So the WSOS will not work unless this service is running, and the WSOS service is not working. So you need to make sure that both services are running. So we can see here Windows internal database is not working. So that means that the WSOS is not working and the SQL is not working. Okay, if we leave it for a couple of minutes, it will start. WSOS service is running. If we leave it, it will start because we have a task or scheduled task to run or to make sure these services are running. Now we will open our console and then we begin working with the MDT console. We'll begin creating two folders. Okay, these folders we have already created them before opening the MDT console. We have a folder named capture share and deployed share. So what we are doing here we are just telling the MDT to point to these folders. Okay, this is only what we have done. So David Brother Barbarius have already created two folders, one for the capture process and one for the deployment process, and he have named them capture share and deployment share. So what we're doing here, we need to point, or let the MDT point to these two folders, and the application layout, this we need to import the applications that will be installed during the capture process of the Windows or the deployment process of the Windows. So let's begin. Now we need to right click on deployment shares and then begin the first step to point. Tell him new deployment share. We will point to the first folder, which is named capture share, and this folder, it's in the E partition, and it will be shared, and the share will be hidden. Okay, why we are sharing this folder? Because the PCs can access it and run the scripts to deploy or to capture the Windows. Okay, so here we will call it MDT capture share. Okay, this is the first folder, and tell him next. And these are something like options. If you go a little bit further, let's see, there is some options. Okay, if we go there, there is some option concerning if you are installing Windows to ask for a product key, to provide local administrator password, if you need to capture an image of this Windows after installing it, if you need to apply BitLocker. All of these we can answer them automatically by using a file called bootstrap.ini. I will show you later that we can uh, pass these questions to be asked. So if you are installing Windows, you will not be asked to answer these questions. It will be asked, or it will be answered automatically through looking to a file called bootstrap.ini. We will configure that later, so take in mind these four questions. Okay, so now we tell him next, next, and then it will begin creating the folder, or it's not creating the folder, it is copying some scripts and things to this folder. So now the folder is prepared. It contains the necessary scripts and files to capture or deploy operating systems, okay, and softwares, of course. So we can see this is the first folder. It's the capture share folder. This is for the capturing process. We will create another, or we'll point to another folder which is named deployment share. Okay, so this is the capture share. Now we need to make the deployment share. And also we have already created this folder before with the necessary permissions. By the way, if you didn't create these two folders and go to the MDT and ask him to create a share, it will create the folder and share it. So you can make it through the MDT, or you can prepare it before using the MDT. And by the way, both you can do that. I prefer to make the MDT, or to create the folders through the MDT and share them through the MDT, because it will add the necessary permissions through the MDT, okay, tool, not as Daniel Brother Barbaris have done. He have already added the permissions manually. Okay, so this is better. You need to leave, or let the MDT assign the permissions to the folders as it likes. Okay, so let's continue and add the capture, sorry, the deployment share. Now it is also hidden. And next, okay, then we have the two folders. Okay, we have two folders, one for the capture process and one for the deployment process. Now we need to prepare these two folders. We need to import the operating system that will be installed and then captured. We need to import it to the MDT capture folder. Okay, so now we need to go and see a couple of things. Before that, we need to go to the MDT deployment toolkit, okay, and go to the extra folders. We can see here Daniel had already had two folders with the same name like we have created in the MDT. He has two folders. These two folders, we will copy them and replace them in the E partition, or replace it with the folders that are created now or that are already created before. So we will copy them and replace them with the two folders in the E partition. Why we do that? Because these two folders contain additional scripts and a folder named log. These folders will contain, or it will record every process done by the MDT. So we are replacing these two folders with the folders that we have created in the E partition. So let's go and see. Now we will copy these two folders, okay, and then replace them in the E partition, okay, and paste. Now they will be replaced, okay, and we will see the difference. If you open the capture share, we will see there is a folder named logs. This was not created before, so the MDT will uh, copy some scripts and folders to this folder, but it doesn't contain the logs folder. Okay, so Daniel has added this folder and add additional scripts that will not be added by default by the MDT tool. So we will go there and see. If we open the custom or the scripts custom folder, we will see that he has added a couple of scripts created by him. Okay, so if you open the custom, we can see these are all scripts done by Daniel Brother Barbarius. So this is the first step. Now we need to go and begin importing the operating systems to the MDT. Okay, so we need to begin preparing our environment. Okay, so now go to the steps, and then this is the layout of the folders in the MDT. So we need to go to the operating systems in the MDT. So this is the capture share. We need to import the operating systems here. Are the operating systems that will be installed and captured. So we need to go to the operating system. We'll create folders, organize the operating systems that will be installed. So we'll make a folder named Windows 10, and in it two subfolders, one for Windows 10 Pro and the other for Windows 10 LTSC. Okay, so we'll create a subfolder. Okay, or first, before that, we need to create a folder for Windows Server. So we have three operating systems that will be captured: one for the Windows Server 2022, one for the Windows 10, and one for the Windows 11 if you seek to install Windows 11. Okay, now we'll create subfolder because I will capture two operating systems, the one Pro, okay, and the other is LTSC. We have discussed before what is LTSC. Okay, so we go to new folder and tell him LTSC. The Pro has a lot of versions. The latest version when I was recording this video was 22H2 as far as I remember. So if we go there and create a folder, okay, we will name it 22H2. Okay, this was the latest version of Windows 10 during the recording of my video. Okay, so now we have done this. As for the LTSC, the latest version was 2021. This was the latest one. Okay, this is the latest version. Okay, so we have everything prepared. So what can we do? We can, again, we need to, there is also other versions of Windows Server 2022. There is the standard version. This is the one that we will install, and there is the data center version. Okay, and these two also have a version like the Windows 2022 or 21H1. So this is basically, we are organizing our operating systems in folders. Okay, so now this is 21H1. This was the latest Windows Server version. Okay, during, or H2 during recording this video. So we have already prepared everything. Now we can do something. We can copy all of these folders and put them in the deployment share. Remember, we will capture an image for each one of these operating systems, and we need to do the same at the deployment share. We need to do that, okay? We need to do that. So what we will do, we will go now and copy these folders, so you don't need to go and create all of these folders again, okay? We will copy these two folders and we'll put them in the deployment share. Remember, we'll capture an image of Windows 10 Pro, Windows 10 LTSC, Windows Server Standard. All of these should be here imported. These images will be imported here, and they will be imported in these folders, okay? So now we can see it is prepared, or it is copied. Now we need to do something here. We need to create a WinPE, or a boot image, that contains the drivers for the PC or the laptop models we have in our network. So this WinPE, or this boot image, will contain the drivers for the models or PC models in our network. So if you are deploying an image, okay, on a model, the drivers for this model will be extracted from the WinPE boot image, okay? So a boot image will be run. We will run a boot image that will deploy a Windows 10 captured image, okay? This boot image contains the drivers for the model that the Windows 10 image will be deployed to. So you can take the model drivers from this WinPE or boot image. So this is what we are doing now. We are creating a WinPE. I have my laptop as Lenovo, so here I will create, or will make a folder for the drivers for the Lenovo model. I have my model as Lenovo, so now I will import the Lenovo drivers, okay, to my boot image, okay? So my boot image will contain my drivers, okay, that are needed to import it, or to be pushed during the deployment of the Windows 10 image, okay? So this is the Lenovo drivers. Here we have something. If you are not familiar how you can export for example, if you have a PC that you need to export the drivers from it and import it to the MDT, this can be done using a PowerShell script. But take care, the exported drivers are non-Microsoft drivers. These are the third-party drivers. Let me show you all a little bit of a script to do that. So if you go to Google Bard has a script to do that. If you have, let me show you all the script to import, sorry, to export. Let's go there. This is how you can go to the PowerShell command and type export Windows driver online destination, the destination to the folder which the drivers will be exported. This contains, we can see here, this contains only the third-party drivers, the display card, the network card, all of this, but this doesn't contain the Windows product drivers, okay? So take care of that, okay? So this is how you can do it. Type it in a PowerShell command and it will export all of the third-party drivers. You can take it and then import it to the MDT, okay? So this is simply doesn't contain any, it's not complicated, very, very simple to do, okay? You need to run the PowerShell script, of course, or run the PowerShell command using administrative privileges, okay? So let's go and continue. If you go there and continue, how much time we have? Okay, so we can see here I will paste the drivers. So this will take some time. So here I'm just opening a text file. I remember, or I'm just taking a note to remember to, okay, this is that I was explaining in a couple of seconds. Remember to say how we can export, okay, laptop or model laptop Lenovo or your PC drivers, okay, using PowerShell. Okay, so we have done this already. Save, and then we can begin. Okay, it will take about 7 minutes. Now we can open and or we can now import the drivers. Okay, so we now import the Lenovo drivers, import, okay, and then we will go and import the drivers. Here you call this is Lenovo, okay, and then we will tell him next, and this will import all of the drivers for the models that you have in your network. If you have more than one model, then you can import more than one driver packages. Okay, so we can see we are importing the drivers, and after importing it we will delete the folder or the source folder. Okay, we can see some yellow warning that doesn't do any harm. Okay, so now we can see that we will see a lot of drivers. Okay, we can see here these are all Realtek, for example, Microsoft, Oracle, Nvidia. Okay, a lot of things actually. So now we have prepared our capture share and our deployment share. Now I am deleting the source folder that contains the drivers. Okay, now we need to begin the importing process, okay, of the operating system. But before that we will do a couple of things. We need to uh, do some configuration to the MDT. Okay, let me show you all. But before that we need to tell him or create something called a selection profile. What is a selection profile? Here we will use this selection profile to force the MDT to use the drivers of Lenovo during the deployment of the image. So we'll tell him drivers when PE. Okay, so what we will do now, tell him drivers when PE, and then we will choose the Lenovo drivers. By this option, we are forcing the MDT to use the Lenovo drivers during the deployment of Windows 10. Okay, so this is the thing. Here we'll go to the packages or out of the box drivers and then tell him to use the Lenovo, okay, drivers. So this is called a selection profile. We will force the MDT to use these drivers. Anyway, so we are working according to the plan. So what we will do now, we need to go and continue the process of the configuration. What we will do now, we need to configure something. Let me show you all. First of all, let's go to Daniel Brother Barbarius folders. Okay, there is uh, two files we will use. One is called bootstrap.ini and another file is called customsetting.ini. So these are two files we need to use or to configure in the MDT. So now go to the rules. We have two things. One is called capture bootstrap.ini and capture custom setting.ini. The same for the deployment, deploy bootstrap.ini and deploy custom setting.ini. What is the bootstrap.ini? I will show you a little bit of a graph that will explain this thing. If you go there and see this, let me show you all MDT. Actually, this one. Okay, this is the bootstrap. Remember, when you begin deployment of an image or capturing even an image, you will be asked a couple of questions. First, you need to provide a username and a password. And if this username, this should be a username and a password in the domain. This will be the user that will be used to connect to the MDT folder that contains the scripts and the Windows source image and the programs. Okay, so this will be used to connect to the MDT capture folder or deployment folder. This user, we have already created it before. It is mdt.user. Remember, we have created a user. This user will be responsible for connecting to the MDT folder that will contain the scripts and the Windows image and the programs, and it will install them. So here we are providing the username and the password, okay, and this we don't need to answer it manually. By editing the bootstrap.ini and providing this info, it will be written automatically. We will not see this window at all. It will disappear, it will not appear, because it is already answered, and it will let you go to the next window. So we are doing this. We are telling him to skip this window, to put this info or this data in these fields, and then continue to the next window. Okay, so this is the bootstrap.ini. We will tell him to use a certain user to connect to the deployment share or the capture share. So this is the first thing. This is the bootstrap.ini. So let's go and do that. Okay, so we'll open the bootstrap.ini. We will see how we can configure this. Remember, this is the mdt.build. Remember, this is the user that we have created earlier. Okay, so we'll copy this setting. Remember, this is the capture share folder. Okay, we have two bootstrap, one for the capture share and one for the deployment share. Okay, remember that. So we will go and do a couple of things. We need to configure the bootstrap.ini. Before that, we need to tell him that we are working with the 64-bit version. Okay, so we will deploy a 64-bit, or supported platform is 64. We are not using a 68 or 86-bit. Okay, so this is one thing. Okay, and then we need to do a couple of things here. We need to go to the rules. Here, this is the custom setting, and this is the bootstrap. Here we will copy and paste, okay, the things in Daniel Brother Bavarius file. Okay, so this is our file, or bootstrap.ini. This is it, and we will tell him apply and okay. And before that, we need to do a couple of things actually. This is the bootstrap, and there is another thing called custom setting. We will open the custom setting and we'll show you all what is the custom setting. Okay, these are a couple of things. I will show you all what they mean during the installation of the Windows. Okay, you or capturing during the installation of the Windows will be asked a couple of questions: the time, the keyboard, the name of the PC. All of these are questions that should be entered or answered manually. The custom.ini will provide the answer automatically and will automate the process of the installation of Windows. So we will copy and paste. So if we try to see here some of the things involved here, so for example, this is the local administrator password. This is provided here. We need, for example, to have the process logged to the logs folder. Okay, this is one thing. We need to skip computer backup. We will not need to backup the PC after installing Windows. We don't need to have BitLocker. Okay, so all of this will be asked during the installation of the Windows through the MDT. Okay, so all of these are answered for us. Okay, and this will help us to automate the process, something like an answer file. Remember, if you are familiar with unattended.xml file, or automating the installation of Windows using an answer file, this is the same. It's the same like the answer file process. Let me show you all also a little bit of a graph here about this process. So we can see here, remember, if we go there, remember, these are things. Okay, this is not actually in the bootstrap.ini. Some of these questions are in the bootstrap.ini, and some of these questions are in the custom setting. So it will be answered here. And during, as you can see here, during the installation, the MDT will ask you about computer details, local and time, computer name, or capture image. All of these are things you need to answer. Okay, so this will be answered for you through the custom setting.ini. So for example, skip capture, skip admin password, skip product key. All of these are here. Skip the task sequence. Okay, you will not choose a task. We will provide the task for you. You not skip applications. We are not installing applications, for example. Okay, or you not choose from applications. I am providing him with applications that he should install. So I will not be given a menu to choose applications to install from. I have already provided for him the applications. Okay, so all of these are done to automate the process of the installation. Skip computer name, for example. I will not give the computer a name. Okay, this will be taken automatically. Okay, from the MDT database. I will show you that later. Joining the domain, we are providing a username that will be used to join the PC to the domain. Where to join or to put this PC in the Active Directory. So all of these are things that will be asked during the installation of the Windows. Skip local selection, skip time zone. Here I am providing the keyboard and the language. So these are all pre-answered questions like an answer file. So this is the custom.ini. So this is why we are doing this, why we are providing the answer file, okay, or are providing these things to the custom.ini. So for example, here he will shut down the PC after the installation of the Windows. By the way, here we will tell him to capture. Here we will see that we will uh, tell him to capture an image from one of these questions. Okay, now this is also a command. Remember, if you have anything in the custom.ini, any line in the custom.ini, and before it there is dot comma, then that means this is a command. It will not be executed. This command you can use to know the time zone that you should use or provide in the custom.ini to provide it during the installation of Windows. So let's see what will be the answer. If you go to the PowerShell and type this command, it will give you the time zone that you can use, or the time zone for your domain controller if you are working in a domain controller. So now I'm opening a PowerShell 7 prompt, and then I will put the command to see my time zone. Okay, so now this is very simple, very straightforward. So are preparing our installation of Windows and software to be automatically. Okay, so after the install, you can see this is Egypt Standard Time. We will copy it and put it in the custom.ini. So all of this we are doing to facilitate the installation of Windows, then the capturing of the Windows and the operating system and the programs. Now this is the WinPE, or this is the boot image that we will use. Okay, so we can see here, for example, we are only using boot image 64-bit version. This is something logic, and there is an option called scratch space size. This is related to the boot image. So we have a boot image that we will use to install the Windows 10 operating system. So there is something related to the boot image, something called scratch space size. What is the scratch space size? If you go to the Google Bard, okay, here I asked him a question. What is the scratch size? Here he give me an answer. Okay, what is Windows scratch space size in MDT and WinPE tab, and why changing it to 512 is useful? Let's see what is the answer.
Windows scratch space size in MDT in the WinPE tab is the amount of memory that is allocated to WinPE for temporary storage. It is used to store log files, temporary files, and other data that is needed by WinPE. The default scratch space size is 32 megabytes for PCs with 1 gigabyte or less of RAM, and 512 megabytes for PCs with more than 1 gigabyte of RAM. However, you can change the scratch space size in the MDT deployment share properties, Windows P tab. Changing the scratch space size to 512 megabytes can be useful for several reasons. It can improve the performance of WinPE, especially on PCs with large amounts of RAM. It can help to prevent WinPE from running out of disk space, especially when running complex tasks such as deploying an operating system or capturing an image. It can allow you to use more powerful WinPE features, such as custom applications and script execution. However, it is important to note that increasing the scratch space size will also increase the amount of time it takes to boot into WinPE. Overall, changing the scratch space size to 512 megabytes is a good practice for most PCs. However, you may want to consider reducing the scratch space size if you have PCs with limited RAM or if you need to boot into WinPE quickly. Here are some examples of when you might want to change the scratch space size to 512 megabytes. You are deploying a new operating system to a PC with a large amount of RAM. You are capturing an image of a PC with a large amount of RAM. You are using custom applications or scripts in WinPE. You are experiencing performance problems with WinPE. Here are some examples of when you might want to reduce the scratch space size. You have PCs with limited RAM. You need to boot into WinPE quickly. You can experiment with different scratch space sizes to find the best setting for your environment.
So this is like caching, okay? It's taking a part of the RAM, okay, to store the Windows PE or some of the files of the boot image. So this will improve the performance, or it will make the boot image load faster. So it will load first the boot image from the server, and then it will be run locally from the machine. Part of it will run from the RAM, which will make it more faster, and the part will run from the local hard disk of the deployed machine. So anyway, this is useful if you need to make the boot image to be loaded quickly. This is why we are changing it from 32 megabyte to 512. So you need to make sure that your deployed Windows 10 machine or VM or virtual machine or PC has a large RAM, so you can deploy the Windows 10 more easy. Okay, so this is why we have the scratch size changed. I think this is it. Is there is any other thing? Okay, so we have done this. Let's go and continue with our lab. So now we have changed the scratch space size. Then we need to enable the monitoring. So if you go to the, before that, we need to make the boot image to include dism command, some commands to be included in the boot image. Okay, dism commandlets and net frame commandlets. Okay, and Windows PowerShell. Okay, let's ask Google Bar the question: what are the dism commandlets and net frame commandlets and why we need to add them to boot images for Windows. So this deployment image servicing and management is a command line tool that can be used to manage Windows images. So this is clear why we need to add it to a boot image, because we are managing uh, or we are deploying an image. Okay, so this commandlets will be useful in deploying images and capturing images, just as those used in WDS. And so this tool will contain or this tools or commandlets will use to manage the WDS and Microsoft Deployment Toolkit. So this is very critical commands that we can use to manage deployed images or something. So some of the most common DISM commands include add a package to Windows image, remove package from Windows image, repair Windows image, capture image. So we can see here these are the commandlets we will need. Actually, we need the capture image command to capture an image. Okay, we can repair an Windows image, remove a program from the Windows image. So these are all useful commandlets we need to add to the boot image. Okay, What is the net frame command? Net is a software development framework that provides developers tools they need to build Windows application. So the net frame includes a number of classes, libraries, so on, so variety of applications. Some of the most common commandlets included the net frame. Install module. This is a very important commandlet to install a PowerShell module. Update a PowerShell module. Let's go further. Uh, Install a module in a PowerShell, import a module. Why we need to add them to boot images? These commands are useful for a variety of tasks: deploying and managing Windows images, troubleshooting Windows problems, developing and running PowerShell scripts. Very, very good. So we need these commandlets because during the deployment, maybe we need, or capturing, we need to run some PowerShell scripts, troubleshooting some problems, deploying and managing Windows images. So this is very, very good. Why we need to add it to the boot image. Okay, so it's useful to boot images, allows you to perform these tasks from a bootable environment. So it's like some commandlets that we can use to troubleshoot problems during the deployment. Okay, so this is basically simple in explanation and fair enough why we need to add these ones. Okay, so now this is good. We need to uh, go to another feature called drivers and patches. Here we will not include any drivers. Okay, we will not install any drivers in the captures Windows 10 images. These drivers will be installed during the deployment of the image. Okay, so we need the last thing to enable the monitoring. Okay, so this will enable logging of the MDT process. Okay, so we have done this. Okay, or we will do that. So we have prepared ourselves. Now the capture share folder is ready. We need to do the same thing in the deployment share. We need to enable monitoring in the deployment share. WinPE, the same rules general, so we need to do that. Okay, so there is a mistake here I have done. I will show you all what was my mistake. So we have already done the custom setting.ini for the capture share folder and the custom setting for the capture share folder. We need to go to the deployment. Now we need to do the same. We need to edit the bootstrap.ini for the deployment share. Okay, this is a bootstrap. Here there is a problem. We can see that it is pointing to the capture share, so this is a problem. Okay, it will not point to the correct folder. It needs to point to the deployment share, not the capture share. So this is a problem I will encounter later. Remember that. Okay, so this is another problem we need to face, or I will face later. So we need to go and do the same. So we will do the same process. We will go to the properties, and then we need to uncheck 86, and then we need to edit the bootstrap. So we are doing the same. Okay, we are doing the same process. Okay, but here there is a problem because it's pointing to the capture share folder. Okay, so now we will save that, and then we'll do the same process. We need to go and add the deployment setting here. Okay, also sorry, the custom.ini. We will go and get one of these. Okay, this will be, I have a variety of it, so these are the custom.ini for the deployment share. Okay, here I am pointing to where is the captured image, what the location, and what are the answers. Okay, what are the questions that will be answered for during the deployment. Okay, so we will do that. I will discuss every line by line when we come to the capture process or the deployment process. Now we need to go to the WinPE and do the same. We need to have the 64-bit and then the scratch size. We will do the same, and we'll go to the features. We will add to the boot image. We will add the same. We will add the dismo commands, and we will add the net frame commands and the PowerShell commandlets. Okay, and as for the drivers and patches, we need to tell him to choose the drivers for the Lenovo. Okay, we'll go there. Okay, not nothing, include selection, not nothing here. No, 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 it's not nothing. We need to choose. This is not correct. We need to tell him to choose the Lenovo drivers. This is not correct. And then enabling uh, the monitoring uh, option. And after that, you need to do something here. So as we can see here, everything seems clear. So if we go further, apply, so here I said before, here we need to choose the WinPE drivers. Okay, drivers for the WinPE. So I will stop here, guys, at minute 29:02, and we'll continue the upcoming video, because I think we have passed 1 hour, okay, and 16 minutes. So hope this video informative for you all, and until the next video, see you all the next video. Thank you so much.